my name is Sara Anani, and this is my Physics 2211 Lab 4. So, in this lab, we're observing and analyzing the motion of a spring with a definite mass attached to it. We're using two programs, Tracker and GlowScript. In Tracker, we're observing the video provided, and in GlowScript, we're making a computational model using the initial conditions observed in Tracker. So the formulas that we're using in this are Newton's second law, the energy principle, kinetic energy, spring potential energy, and gravitational potential energy. So using Tracker, we're calculating K and L naught, where K stands for the spring constant and L naught stands for the relaxed spring length. We know the formula T equals 2 pi root m by K, which can be rewritten as K equals 4 pi square m by T square. So if we find the mass and the time, we can definitely find K. Then to find the relaxed spring length, we know that F grav equals Fs, so mg equals Ks, where S stands for L minus L naught. Thus, expanding it out, it can be rewritten this way. So we know that mass equals 0.402 kg, and we're going to use this in Tracker. So we find the position minus 0.116 minus 0.637, 0, and here is me plotting y versus time. So using this, I found out my time for one oscillation equals 2.308 seconds, my spring constant equal to 6.87 newtons per meter, L naught equal to 0.123 meter, and L equal to 0.7 meters. I'm going to use this in GlowScript. Thus, using the code provided, I updated my ball mass, ball position, and ball velocity, defining my G, my spring constant, my L naught, and then I have plugged in the formulas that I have stated above. Here's a screenshot of my calculations. I have calculated F grav, F spring, and F net, and then I have used Newton's second law as used in the previous labs to calculate ball.well and ball.pause. Then I'm using energy principle to calculate the rest and then plotting it out. Here's a screenshot of my graphs and just another picture of my computational model. My D of kinetic energy is represented in blue, my U grav is represented in red, my US is represented in green, and my delta E is represented in orange, which we can see is constant 0. And there's a picture of my Y position versus time, where the red one is the one observed in Tracker, and my blue is the observed computerized one. So the change in Tracker versus computerized may be due to the center of mass not being selected accurately or other dissipative force that I have not used in GlowScript. So what does this mean? For my model system, is the energy principle satisfied? Justify your answer by briefly discussing your plot of energy changes. So as I had observed in my previous one, with all my dk, ug, us, and de, we could see that the de was a constant 0. It's a triangle E is a delta E is a horizontal line at 0. So thus we can say that the energy principle is satisfied. Question 2. Using the tracker obtained in Tracker, make two separate estimates of oscillation periods. First by estimating the period of oscillation from X position data, and second by estimating the period of oscillation from the Y position data. Compare the two estimates and discuss. So here's my screenshot. My left one shows the position versus time in the Y direction, while my right one shows the one in the X direction. As we can see, the oscillation is almost exactly the same. There's a very low percentage of error, but there definitely is an error. This may be due to L not being a constant value and due to just my errors when collecting data in Tracker.